All right, so in this tutorial, I'm going to walk you through a common pattern that we see in AI development, and that is combining internal knowledge from, for example, a handbook with web search. And web search can either be a specific URL that we already know beforehand, where we just want to get the data from that page, or a broader search where we let the agent go on and on in loops, collect the information, and then use that as context. So this is a request that we see more and more from our clients, where they want to build internal agents that have a RAG pipeline, they have access to internal knowledge, but we add the web on top of that, usually in fallback scenarios. So that's what I want to cover in this video. Now, high level, if we go to the image over here, what that looks like is we'll build an agent that can take a user query that will then decide, and the agent will then decide to say, look, I can look into the internal policies, into the handbook that I have, or I can either search for a specific URL, or I can do a web search, and then we also filter by domains. So we can keep it very focused and just go through the sources that the client, for example, has specified. We will bring all of that together, synthesize the information, and reply in a structured way, and then also give all of these citations back to the user. And now, quick disclaimer, in this video, I'm going to assume you already understand how to work with OpenAI, structured output, use tools, and RAG. If you're new to that, check out the link below where I'll introduce you the basic building blocks of working with AI agents. All right, so let's get started. Now, this tutorial is going to be very hands-on. I will walk you through these code examples. So first, we're going to start with getting a single page and provide that to the agent. Then we'll do the broader web search. Then we'll search the handbook. Then we'll bring all of that together in a search agent. And then in 5, we'll wrap this in an interactive agent that we can chat with via the terminal. So all components and patterns that you can very easily reuse throughout your builds. So let's get started working with a single page. And I'm going to show you how to do this with the OpenAI API. So if you want to follow along, make sure to plug your API key in. But this can be done with a lot of model providers nowadays. This can also be done with Google, with Anthropic, with Grok, or with OpenAI. The patterns are literally the same. So we're going to work with a GPT 4.1 Nano model in these early examples to keep things very fast. All right, so getting a single web page. What does it mean? What's the goal? Well, whenever a user asks something about a specific page where they plug in a URL, we want the AI to grab the HTML that is on that web page and get it into a format where we can easily send that to an LLM so it can interpret that. Now, there is a very good library for that we can use for this, and that is Docling. I have an entire video on that. It's a simple pip install. It's very easy to use. I'll show you how to do it here. But if you want the entire rundown of how to use that, I'll link the other video below. So right now, I'm just going to start this up, and we're just going to walk through this step by step for you to get a feel for what this looks like when we start with a single page. I first define some data models. We're going to use these later. So I'll pretty much say, look, one data model that we have over here is going to be a URL, and we can validate that. And later, we also want the model to generate a summary. So these are pydantic models. You can ignore those for now. Then we have a URL over here that we're going to test. So let me actually plug this into the browser so we can also see what we got going on here. So this is the EU AI Act. It's a page where a lot of stuff is explained about that EU AI Act. So that's what we will be using. Okay, that's the starting point. Now I'm going to plug that into the pydantic base model just for validation, because I always really like to build my AI agents very type safe using pydantic. And now here's what the first step that we can do to get the HTML content from this page. We use the converter over here that I'm scrolling up a little bit here, that we established over here. So this is the Docling document converter that we import. And now this is simply what we can use. So let me show you what that looks like. If we use Docling to get the page, it will print some logging info over here. Then in the page content, you can see we have a conversion result over here. And what I can do using that, I can call .document.export to markdown. So if I run this and then print this, you'll find that we now have an entire markdown file over here. Let me actually scroll all the way to the top. So you can see, there we go, the EU AI Act, first regulation on artificial intelligence. So this matches what we see here on the website. So this is already super convenient to get started. It's really easy. All we need is docling, and we need to call convert and convert it to markdown. Now, then passing that to an LLM is super straightforward. So we have some simple instructions in here, and then we simply ask it to give a short summary of the website. So this is nothing really spectacular here. We're just using an LLM to create a summary of the website over here, and then the final result that you see over here, it summarizes it. So the only thing that I want to introduce in this file is the first piece of the puzzle, and that is getting or turning HTML into Markdown so we can use it for our LLMs. Okay, so that was step number 1. So then we get to step number 2. This is where it gets a little bit more interesting because now we're going to do a broader web search. So this is already a lot more agentic and a lot more dynamic. And I'm also going to use a reasoning model for this. So we're going to use GPT-5. We're going to use the nano version, which is a little bit quicker because reasoning models generally take a lot longer. So this is just something that you can control. If you have a lot of time, you can just use GPT-5. You can use the mini version. The nano is the fastest in this case. So again, we're going to start with some Pydantic base models where we want a search result, but now we also want the citations because this is important because now we're going to crawl the internet and we're not really sure where we're going to go or where we're going to end up. So whenever we send something back to the user, we want to make sure that we have the citations. And again, we're just going to walk you through this step by step just to see what that looks like when you implement it with the OpenAI API. So for this example, I'm going to list some Dutch websites here related to the government, because for a lot of our clients are actually governmental agencies, and they have to deal with a lot of policy documents, a lot of policy writings. And that's where use cases like this and integrating that into an AI assistant can really be handy. So we select the allowed domains that the agent can use. And then we start with a simple query. So what are the current policies that we got going on over here? We store that as well. And then this is where the magic happens. So let me actually zoom out a little bit so we can see the entire call that we're going to make here. So let me check if everything is good. Here you can see that we're using the OpenAI Responses API. We use the model. We set the reasoning effort to medium. And now we're going to specify a tool. And OpenAI has a built-in tool for a web search. So you can also look up the documentation over here. So if we do OpenAI web search, you can find the specifics for the API. This covers everything that there is to this API, but I will show you the basics over here. So the syntax, in order to use this tool, you need to type web search, and then we can implement some filters in here. Like I said, this is very useful because this is how we can restrict the web search to a certain list of domains. We can set the tool choice to auto, and we also want to include all these sources. So this is important. Then we take the input, which is the user query. So this is what the user would be sending to your system. We have instructions over here, and then we also can specify the text format, which is the Pydantic model that we specified earlier, right? So if I scroll up a little bit to the top of this file, you can see the search result is identified where we say, look, you're going to do a search, you're going to take the user query, and what I want back is a search result model where one key is the answer. That's a string. So give me your answer. But I also want citations. And the citations is a list of a citation-based model that we specified over here with the text and the URL. So this is going to be really helpful because now if we come over here and I plug all of this in, and you can see I can start to run this. So this will take a little bit because now behind the scenes, the agent will literally start to perform the search and the crawling on the internet using, if I scroll up, GPT-5 Nano to interpret all of these results, to use reasoning to figure out if it should go into a certain direction, if it should do another search. And then once this is finished, we'll get back to the results over here. All right, and there we have our results over here, which we can print and do a model dump JSON. And as you can see, if I scroll all the way back to the top of this file, you can see that this is now in the format of our search result. So we can clearly see our answer over here that we can now print and send back to the user. But we also have our citations, which we can, for example, use in our front-end application to list those as well. So now if I scroll all the way to the bottom over here and, for example, want to take the result and I just want to take the answer, for example, and get that out of here and maybe do a print statement on there, you can see that here we now have the complete answer and all of the sources that it went through using this search. And we can quickly validate if it listened to our request to only look at these specific domains. And you can see we had Rijksoverheid, Tweede Kamer, CBS. So that all looks good. It even includes subdomains. So this is already a super powerful feature of the OpenAI API to do very directed searches. And now if you use reasoning models over here, like for example GPT-5, Mini, Nano, or the regular one, you'll generally get really good results out of the box with this already. It can take quite some time for this to finish. So if latency is really an issue, you want to scale down to some of the faster non-reasoning models. All right, so that's how you search the internet with your AI agents. Then let's get into the final piece of the puzzle before we bring them together, and that's using internal knowledge. So in this example, I'm going to simply load a handbook. So this is a markdown file. This is just some made up information, some internal instructions that a company may use. Now, in this example, we're not going to build out an entire RAG pipeline. The handbook, the markdown file, is short enough to take in its entirety and just like add to the context of the language model. In a production environment with more information, you probably want to make this more clever, build a RAG pipeline, but that's not the goal of this video. I have other videos on how to do that. So I'm going to walk through this quickly because it's super simple. We use the handbook, we load that, and then we have a simple function over here that we're going to use to retrieve the information from the handbook if the AI thinks it needs to do that. So we have a tool definition for that. And then let me scroll all the way down to the bottom. This is then where the magic happens. If we ask the AI agent to answer a specific question from the handbook, it will perform a tool call to get the handbook and then use that information to execute the function and then do another call to OpenAI in order to then get the answer back. And here again, we use pydantic models to say, look, we want an answer and we want citations. Okay, so that's high level what we're going to do here. Let's go through this step by step and run it so we get a feel for what this looks like, right? So we're using GPT 4.1 Nano here, not a reasoning model, so we can go quickly. And then we have the function over here to search the handbook, which is pretty much just going to read the entire handbook path and return that as text. Then we have a tool definition for that, which we're going to provide to our API call. So the LLM understands, look, whenever there is something that is not inside my information right now that I can check in the handbook, then I will use that tool in order to retrieve it. Okay, so then we're going to set that up and we're going to specify the agent, model, input messages, and a simple instruction there. And then if I scroll all the way down to the bottom where we're going to run this, what we can now see, if we have some simple queries, because we've now specified as a tool call, the agent will not always look into the handbook, only when it thinks it needs to access the handbook. So this is a core part of how we are going to bring all of these mechanisms together that I already want to illustrate over here. So if we have the following examples, for example, we ask this specific agent, like, look, what can you do? And then we ask it, what are the requirements for registering an AI system? With the first one, it should just reference the internal instructions of the agent without needing to look into the handbook. So let's have a look at what that looks like. And I have a nice print statement over here that's going to walk us through this step by step. So first it will say, look, if we ask it, what can you do? The agent decides there's no tool call needed. I'm going to respond directly. And it will simply reply based on the information from the system prompt. That's what you see over here. Then for the second question, what are the requirements for registering an AI systems, etc.? It's jumping a little bit. Sorry for that because it's still running. You can see that it's decided to call the tool. It retrieved the handbook with so many characters in there. Then it answered the question. And here are these specific citations that directly reflect to the handbook. This is all possible because of structured output and the model that we have specified all the way at the top. Remember, that's how we can split between the answer and the citations and keep it super easy and convenient for the end user to view where this is coming from. And a real quick little side note from my end, because in the beginning of this video, I told you how this is a very common request that we get from our clients nowadays, right? And I actually run an AI development company called Datalumina. I've been running that for 7 years already, but it didn't start out as the AI development company that it is right now. It started as me just being a freelancer and working directly one-on-one with clients. And I know that a lot of you guys following are developers that are also interested in taking on side gigs, maybe even doing it full time, also as a freelancer, but that it's very weird or hard in the beginning to land that first client and you really have no idea what to start. So if that sounds like you and you're interested in that, make sure to check out the first link in the description. There's a video of me going over how I can help you with that. All right, so that was puzzle piece number 3. We got single web page, web search, and search in the handbook. Now let's go to file number 4 and see how we can bring all of this together in a dynamic agent. And really the key thing here is to split up our code and to create some simple abstractions so it doesn't become this one gigantic file with a lot of things going on. So what I always like to do is I like to create a folder called tools, and in there I'm going to specify the tools that our agent can use. So what I've essentially done is for all of the functionality, so getting a single web page, getting or searching through the handbook, and doing the web search, I created a simple tool. And this is just a repetition of all what we already did, right? So for the get web page, you can see that, look, we're using docling. We learned that we can use the convert function in there. And we also by now understand how we can specify a tool. So that's just a simple repetition of what we've already done, but now in a tools folder. So that now when we come to our search agent, you can see that we can create this import statement over here to get all of the right tools into our file. And then now all of a sudden our tool definition, instead of being a few hundred lines of code, can now just be the following definition over here. So this is a little tip that I want to give you whenever you get more serious about AI engineering and coding in general. This is how you want to think about structuring your files. And then since we now can create an agent with all of the tools in here and a little bit of clever prompting strategies, we can now bring all of this together. So if I scroll a little bit down, you can see that we now have an ask agent function where now we have the tools in here and then always the functionality that we use to go through the OpenAI outputs to see, like, look, if it decided to use a tool, we also need to go ahead and call the tool. And I've added a couple of print statements for us to actually see what's going on. So if I then scroll down to the bottom over here, you can see a couple of examples here. And this is where it will get really cool because this is really where it will come together. So for every example that is in here, it will first tell you what the scenario is. So number 1 will be a question where it will not use a tool and it will do a direct response. So for example, what can you do? Then number 2 is to search the handbook only, then get a specific web page, then do the web search, and then use multiple tool calls. So let's have a look at what that now looks like when we bring all of that together in those tools, make them available to the agent. This is really where you unlock the power of this assistant and how you can integrate this into agents that you could actually implement for clients, now being able to draw from all of these various different sources. So you will see that we start with the first response over here. So this is going to be a quick one because it's going to directly answer, say, look, here's what I can do. Now then we're going to search the handbook, which will also be relatively quick, and so on. You get the idea. So the goal is not to get in all of these very detailed specific examples here, but just show you the overall patterns about how to think about this, how you can bring these different agents, functionalities, or they're literally just tools, how you can bring them together, and then how we can essentially use prompting around that to steer the behavior of our agent. And then the beauty of this system over here is that you can see for the final example that it first decides that it needs to search the handbook, but then it also continues to get a web page because the instructions was pretty much first search the handbook for the requirements and then also search this. So this system is flexible enough to work with multiple tools. And now this is an example of just 2, but this can also go on and on and on. And nowadays AIs, especially if you use the heavier, the more advanced models, you can easily get away with adding 15, maybe even 20 different tools at the same time. Now this is definitely not always a best practice and you may want to split it up, but they are capable enough of doing that. So now the final answer over here is an answer based on information that is in the handbook and also doing a search on a specific URL. So that is how we bring all of this together in the search agent. And then as file number 5, just as an example for you to play with, Here is an interactive agent that you can run. You should run this in the terminal. And now we also keep track of the history in here. So I can ask like, hey, what can you help with? And now it will keep track of the turns in there. It will update the memory. So this is just in the previous examples, it was just like doing a question and then an answer, right? Here we can continue the conversation like you would actually do in a real AI assistant. So you can give that a try if you want as well. So that's how you combine internal knowledge with the web search. The diagram that you see over here, we have now implemented that. And as with all of the examples that I share within my cookbook, really the goal is not to give complete solutions, but isolated snippets. So whenever you have to build something like this, you know, oh, what, Dave had a video about this and some code examples, so you can quickly get going. Because like I've said, recently, we had a lot of client builds where we need to integrate this exact functionality. And I had to do some digging as to, okay, what's the best way to get a single page? How does the web search functionality work using OpenAI? Do we want to use a reasoning model? How do I tweak the parameters? How can I adjust the domains there? And that all in all just like takes a couple of hours of work to figure out. And through this video, hopefully now you understand this in like, I think just under 20 minutes or so. So that's it for this video. If you found it helpful, please leave a like and also consider subscribing. And then what I will do next, if you are serious about AI engineering, I will list a video over here which I think you will like and which I recommend to check out right now. So go do that right now. Click on this video and then I'll see you in the next one.